Welcome everybody to this video, and in this video I'm gonna talk of how we can find the derivatives of natural exponential functions that contain exponential functions, natural exponential functions, how we can find their derivative. And of course, as usual, I will be putting the rule, writing the rule at the end of the video. But first, I will just give you a few examples of how the rule works before I write it down. Okay, let's say we have this function y is equals to 2 e power negative x plus e power 3x. Assume we have such a function, how can we find its derivative? So the way to find its derivative is going to be like this: y prime would be, so what we will do is we will multiply the coefficient of x here with this number before the exponential e. Okay, so when we multiply it becomes negative 2, because this is negative 1, right? Negative 1 times 2 will be negative 2, and then we differentiate e power negative x. It will not change, so it will just be e power negative x. Okay, so we will just take whichever number before the x, and then we multiply it with the number before the exponential function. That is the same thing we are going to do here. In the second thing, we will just multiply this number with this number with the number before the exponential, before the e, so it becomes 3 e power 3x, and then we maintain whatever. So the thing is, we will just remove whichever number in front of the x, and then we multiply it with the number before the exponential. Okay, so let's say we want to find the second derivative. Okay, the second derivative. So here the same thing, what we will do is just we are going to multiply that number before the x with the number before the exponential. So it becomes 2, because negative 1 times negative 2, it becomes 2 e power negative x, the same thing. And here also 3 times 3, that is 9 e power 3x. I guess you must have seen the pattern, and that is it. So if you want to continue finding the y triple prime or the third derivative, you just do the same thing, which will be, let's say this is our third derivative, so we will just multiply that negative 1 with 2, it becomes negative 2 e power negative x plus 3 times 9, 27 e power 3x, and so on and so forth. Okay, let's take another example. Let's say we have another function which is now a little bit more than that one, so it becomes, let's say we have y is equals to x power 9 over 4 plus e power negative 2x. Okay, let's say we have that one. Now to find its first derivative, it's gonna be, first this one we already know from the power rule. We are going to bring this down, so it becomes 9 over 4 x, and then we're going to subtract 1 from the power. That will give us 5 over 4. Okay, so it just gives us 5 over 4. Now here is the thing, how about this? And this is just the same thing. We're going to multiply the negative 2 here with the number before the e, so it becomes negative 2 e power, and then we will maintain it negative 2x. Okay, so that is it. So if we go on and find the second derivative, it will be just the same way. For this one, we will have to bring this one and multiply it here. It becomes 45 out of 16 x power a quarter. If you subtract 1 here, and then here it will be plus, because when you multiply negative 2 times negative 2 becomes plus 4 e power negative 2x. Okay, so let's just write the rule now, because I think you must have understood. So the rule is, if you want to find the derivative d all over dx of an exponential function e power x, then it's gonna give you the same thing, e power x. Okay, so that is the rule. It's not gonna change, and you must have seen somewhere when we were calculating, it wasn't changing the e power x. All that was changing is the number, the coefficient before the x, whichever number that will going to be here. Okay, that's the one that you will bring down, but the rest of the structure will remain the same. Okay, so hope you enjoyed this video and you must have understood it. If you didn't understand, you may play it again and again. If you are new to the channel, you might consider subscribing and then clicking the like button and then the ring, so that whatever new from us can reach you. Also, you could follow us in Facebook and put your comments there, and even here in the comments in the YouTube as well. Thank you, everybody. See you in the next video.